This is I do, you do answers for proportional relationships. First one says determine if each relationship is proportional. So let's look at A. A, to be a proportional graph, it needs to have a couple things. It needs to be in a straight line. Is it in a straight line? Yes. It needs to be going uphill. It has a positive slope going uphill. And it must hit the origin or the point 0, 0, which it is hitting 0, 0. So it is going uphill in a straight line, hits 0, 0. That thing is proportional. So your answer for the A is yes. B, as an equation. As an equation, it needs to have a constant rate of change, which it does, right? And it can't have a boyfriend or a y-intercept. I call that your mama's ex-boyfriend, just to get people to remember it. If it's proportional, there will be an understood boyfriend of 0, because remember, that y, let me rewrite it out there, that B right there stands for where it hits the y-axis. So if we go back to my graph, it hits the y-axis at 0, so I could write that as y equals mx plus 0, but that 0 disappears, that's its identity, and it should be in the format y equals mx. So that one is not proportional because it doesn't hit at 0, 0, it hits at negative 1. All right, let's go to C. To be proportional, these would have to have the same constant ratio. So if you take y divided by x, well, on the first one, 4 divided by 1 is 4, and 8 divided by 5 is 1.6. They do not match, so it is not proportional. So we have yes for A, no for B, and no for C. I'm going to write them in different places because I'm running out of room. I would check D in a very similar way. I would just take y divided by x. So on the first one, I would take 6 divided by 2, which is 3. And then I would take 15 divided by 5, which is 3. And 27 divided by 9, which is 3. And 33 divided by 11, which is 3. They always match, so we have a constant ratio. In fact, to let you know what that would look like, you would write it like this: y equals 3x. No adjustment had to be made, so that's what it would look like as an equation. Then I could graph it out of slope-intercept form, knowing that since there's no number back there in the y-intercept spot, that the y-intercept is 0, and then it goes in a slope of up 3, right 1. So up 1, 2, 3, right 1. That's hard to draw on here. 1, 2, 3, right 1. So it would graph something like that, and it does hit 0, 0. It goes uphill, right, in a straight line. Not sure I said that on the last one, so let me reiterate. That was a yes, uphill straight line through 0, 0. That was a no, because it did not hit at 0, 0. It hit at negative 1. We had an adjustment there. There will be no addition and subtraction in proportional relationships. That was a no. When I divided y by x, I got different answers, so I did not have a constant ratio. And this was a yes. Every time I divided them, I got 3, 3, 3. That is the constant rate of change. That's the constant proportionality. This is a proportion. It's a ratio equal to a ratio. We have a shortcut for doing that. Let me just put a variable in there so you can see it. Remember, what we know is the cross products are equal, so 20 times 8, which is 160, has to be equal to 3 times n, because the cross products are always equal in this. So I'd be in an algebraic equation, so I divide by 3 and divide by 3. I get m equals 53.3 repeating. Now, the shortcut is take the two that are diagonal from each other. That would be the 20 and the 8, multiply them, and then divide by the other one. So you multiply the diagonals, divide by the other one. It says round to the nearest tenth up there, so I should round that to 53.3. Now we're going to practice setting up a proportion to be able to solve it. So it says on a map, 3 inches represents 75 miles. 3 inches, 75 miles. These two are connected. That's how much they've shrunk it. 75 miles shrunk to 3 inches. That's the scale that they used. Now, once I know that, I put my labels on it because that makes it crazy easy, because all I have to do is locate what I need to know, which is what is 240 miles. So I'm not going to put that on top. That's the inches. I'm going to put it on the bottom because the labels match. So 3 inches is to 75 miles, as some unknown that I don't know yet is to 240 miles. So again, I multiply my diagonals and I divide by the other one, and I get 9.6. And remember, I already know the label because it's right up here, so the label is 9.6 inches. This is just so you start to understand the connections that are inside a proportion. It says which number in the proportion has no special connection to k. Well, k is related to 12 because it's the same part of the ratio. It's the top of the ratio. And k is in a ratio with 4, so they're related. The one that k has nothing to do with is its diagonal. And I always use hat is to head as shoe is to foot. Hat and head have a relationship. Hat is the clothing article that goes on your head, and hat also has a relationship to shoe because they're both articles of clothing. Does that make sense? But hat and foot have nothing to do with each other. They don't go together. You don't wear your hat on your foot. They're not both body parts. They're not both articles of clothing. And the same is true for shoe and head. They have nothing to do with each other. So the one that has nothing to do with k is 18. If I asked you which one has nothing to do with 4, your answer would be 12. The one diagonal has nothing to do with it. We can use it to solve with cross products, but it has nothing to do with it. It doesn't have a special relationship. It says set up a proportion to solve. So let me go ahead and get my proportion set up. Graham walks 1/2 mile in 3/5 hours. Miles per hour. I'm going to go ahead and label that now. That's 1/2 mile in 3/5 of an hour. Some people freak out because they see this. Remember, this is just a ratio, right? A rate of how many miles per hour. It's just that they happen to be fractions. Now it says how long would it take him to walk 8 miles? You already have your labels there, so it obviously doesn't go on the bottom. It goes on the top, and you are ready to multiply and divide. And you get your answer of 9 3/5. And remember, you already have your label set up. 9 3/5 hours. The ratio of sugar to flour in a recipe is 3 to 4. I'm going to go ahead and write that as a ratio up and down. And I have to make sure I use my labels correctly. So the ratio of sugar to flour, so 3 is the sugar and 4 is the flour. If you enlarge the recipe so that you need 20 parts sugar, notice I put it up there with the S because that's 20 parts sugar, how many parts of flour will you need? Well, once again, you're ready to multiply the diagonals, divide by the other one. When you do this, you get 26.6 repeating. Now, I already know my label is F for flour, right? Parts flour is really what it is because we're not sure if that's tablespoons or cups or what that is. But it also says round your answer to the nearest tenth. Remember, the tenths is the one right behind the decimal. You have to look behind it. That 6 makes it go up to 26.7, and your answer is 26.7 parts of flour.